try this again. Linear function. Linear functions. When you graph them, what do you get? A line. Linear functions are that simple. They're the ones that just make straight lines. So a linear function forms a straight line. So if you have just a graph and you see that it's a dead straight line, you know you have a linear function. You don't even need the function. You can figure it out from the fact that it's just a straight line. It has one blank and one blank. Any suggestions? Has a slope and a y-intercept. We would say for this one y-intercept, one x-intercept. So your typical linear equations, one x-intercept, one y-intercept. Our typical linear equations go through both at some point. Find the x and the y-intercepts of the line y equals 4x minus 1. If you're ever asked to find an intercept, no matter what the question is, a really easy way to do it, if you want to find, even easier than graphing, if you want to find the y-intercept, what do you know about y-intercepts? Colton. Yeah, in this question it's always the b value or the minus 1. But there's something else you know about it. Keely. Make x 0. Any equation you're ever given, if you're looking for the y-intercept, you can change x to be 0, and the result will be your y-intercept. So conversely, if you want to find your x-intercept, what do you know about y? Make it 0. So if we want the x-intercept for this one, make y 0. And then just solve for x. So the x-intercept we're going to solve for right now. The y-intercept, Colton already told us, is minus 1, which is true. If you make x 0, 0 times 4 is 0, minus 1, so minus 1 is your intercept. Let's look for the other one, the x-intercept. If you want the x-intercept, make y 0. So you have 0 equals 4x minus 1. And then isolate for x. Move 1 to the other side, and then divide by 4. 1/4 equals x. That would be your x-intercept. Yeah, it would be at 1/4, comma 0. So it would cross the x-intercept at the point 1/4. So if you were to graph this, like this, the y-intercept is at minus 1 down here, and the x-intercept is at 1/4 over here. That would be our graph. You should be able to solve those algebraically. It's better than having to depend on a calculator forever.
Wait, what's the
The x-intercept was positive 1/4. Add 1 to both sides, divide by 4. Okay. Linear functions all have a constant length. Slope. Linear functions all have a constant slope. Slopes can be found two ways. If you're given 2 points on a graph, you do rise over run, or you use this fancy little equation. You pick one point, you call it point 2. You pick another point, you call it point 1. y2, so the value of y at point 2, minus the value of y at point 1, divided by the value of x at point 2 minus the value of x at point 1. That's a fancy way of saying rise over run. That's exactly what that is. Finding the difference in your y values is finding the rise, the height. Finding the difference in the x values is the run, how far along to the sides it moves. If you have an equation in y equals mx plus b, what's your slope? M. Your m is your slope, your b is your y-intercept. If it's in that formula, which you're going to see a lot, it's nice and easy to see. We're not going to do a lot of questions on this stuff. Just so you know. But it's good review to make sure you know what's happening. If we look at this equation right here, go to the bottom. Example, find the slope. To find the slope of that equation, you need to isolate y by itself. So you would move the 4y over. So it was 4y. Look at everything. And then just divide everything by 4. And that would give you your slope and your y-intercept. That's called general form, 0 equals. And that's how we write our quadratics, which is going to be important. So yeah, good terminology. What makes a function a function? Ty.
It's not like a curvy line or like a straight line through.
What do we call that? You're right.
Oh,
Vertical line test. Yeah. So a function is something that passes the vertical line test. So that means, yeah, there's lots of ways to say it. So we're going to break it down in this one. So a function is a blank that either passes the, this is vertical line test, vertical line test. What's the first blank going to be though? A function is a equation. A function is an equation that passes the vertical line test, the VLT, or does not repeat any x values. So if you get a list of points, and say the first one you get is 1, 0, and the second point you get is 1, 2, you have repeated x values. So it wouldn't be a function. Linear equations are blank functions if they have both blank and blank variables, or only a blank variable. Whew. That's a lot of blanks. I don't know how you're supposed to figure that out. Linear equations are only functions if they have both x and y. Okay, so let's see first. Linear equations are only functions linear, yeah, that doesn't work, eh? I meant to put linear. They're only linear functions if they have both x and y variables, or only a blank variable. If you had to get rid of your x or your y variable, which one could you get rid of? You could get rid of your x. So, or only a y variable. And we're going to talk about why that makes sense. If you had only a y variable given, you would have something like y equals 2. Correct? Only a y variable is given. If you drew that line, it's a horizontal line, which means it would pass the vertical line test. If you did x equals 2, that's a straight up and down line, which would fail the vertical line test. So you need to have a y variable. It's a must-have. Y was vertical? that's what's so confusing, because the y-axis is the vertical one, right? But if you say y equals 2, it's all the spots on the graph where y is 2. So y is 2 about here, let's say. So it'd be here, 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 all the way across to create a nice horizontal line. So that's why we usually get those mixed up. That's a pretty typical confused thing. Blank variable equations form blank lines, which pass the blank. I just say what would make sense right here? Y variable equations form horizontal lines. Which pass the VLT, which is exactly what we just talked about. We're just filling out what we just talked about. Lines with both variables are called, what do we do if we have both variables? Yeah, linear.
Oh.
It's linear. If it has an x and a y, it's linear. Which is just another name for straight. That's all it is, right? It's just straight. Yeah, it's not linear. No. Okay. Are these functions? And I know that a lot of this is review, but we got to do it. Oh, good. Is this a function? What's the test we do to see if something is a function? The vertical line test. There's no graph here. Draw it. Draw the graph. So each thing is a point. So the first point they give you is 3, 6. Way up there. That's your first point. Your second point is 4, 6. Then you have 5, 5. And 6, 2. And then 7, 1. Is that a function?
Sure is.
Yeah.
Not the same.
Yeah. So before you even draw it, if you just looked at your x column, it doesn't have any repetitions. It's going to be a function, because that's the other thing we said. If the x value doesn't repeat, you have a function. Does our x value ever repeat? No. You have yourself a function. Okay, function notation. There's a whole bunch of jibber jabber here. Logan? Yes, sir. There's a whole bunch of stuff here. All you need to know, function notation is when you see f of x. That's function notation. So if you get told to write something in function notation, it needs to say f of x is equal to, rather than y is equal to. Good question. What is a function? A function is something that passes the vertical line test. If you see f of x is equal to something, they're telling you it's a function. They're telling you it passes the vertical line test. If they don't write it f of x, this one right here, y equals x squared minus 1. It might still be a function, but you're not sure.
Why does it like relate to why we need to know if it passes the vertical line? What does that do to write our? I know that's
And why does it matter if it's a function?
Yes. Is it related something further, or is it just because?
Yeah, I don't know if we get into that any further. I'm trying to think if grade 12 does. Not really. All that you're trying to draw from it is that your x values don't repeat, and I don't think you get into it any further in grade 12. Not until university. A good thing to know is that it means you're not getting repeating x values, which means if you're using a function instead of data, that's important. That you can't have repeating x values. If you made a function that wasn't a function and it's actually just an equation, and you tried to apply it to an actual question, it wouldn't make sense. So if you were trying to do like days of the year and temperature or something, and you had multiple days of the year that would end up on your thing, it means you didn't make a function, you made an equation. It doesn't work. But we don't really get into that so much. It's just knowing what a function is and knowing what an equation is. And I don't think you I don't know where you get into it, not till university. Or calculus. If you go into calculus, you might see this stuff. Okay. Example 1. Write the equation y equals x squared minus 1 in function notation. All you do is you change your y to f of x. So f of x is equal to x squared minus 1. That's function notation. It's that easy. It's just knowing the terminology that function notation means f of x. The x squared. Yeah. You don't have to do that x in brackets until you sub something in. So if you look at example 2, which is kind of low, it says find f of 3 if f of x is equal to this equation. That's when you use your brackets. So you guys are pretty good at this stuff because I saw you do it on your test already. You take that 3 and you sub it in anywhere you see an x. So it will become 4 times 3 cubed plus 1 all divided by 2 times 3. That's when you use brackets. And it is important that you use brackets there. 3 cubed is 27 times 4 is 108 plus 1 is 109 divided by 6. That's not a good number. What is it? 109 divided by 6. There you go. That would be your answer. F at 3 is equal to 18.1666666. Right now, what you've done up to this point, right now, is review. Or should have been some sort of review. So now, grade 11, math 20, we move on into quadratic functions. So quadratic functions are going to be functions that aren't straight lines. A quadratic equation is any equation that can be written in this form, which we've actually already been practicing. That's where you go ax squared plus bx plus c. Where a, b, and c are constants, so just numbers, and a cannot equal 0. This is also known as general form, which Kai already told us. Because it's all equal to 0, that's general form. A can be a negative. Yeah, that's when we had with a y in there. This is a quadratic in general form. That was a linear in general form. You couldn't have a negative. Which of the following are quadratic equations? Is A going to be a quadratic equation? Yes, it is. Good question. If we look at this form right here, the only things that you need is A and B 0. Is A 0? No, it's 1. What's our B value?
0.
Our B value is 0. So if there's no x, just like there's no x in here, there's no middle term, that just means your b value is 0, which that's allowed. And then what's your c value? -9. So yes, that is a function, or sorry, a quadratic equation.
So just for the first over like
Just a, yep. The best way to think about it is x squared has to be there. You have to see x squared somewhere. And you can't see anything bigger than x squared. So you can't have an x3 or an x4. X squared is your biggest one. You could have like 100x squared. Just the x squared has to be there. You just can't have 0 times x squared. In all honesty, that's the way I look at it, is either an x squared, is it the biggest like exponent on an x? And if those two things are right, then yes, it's quadratic. Look at this one. Is that quadratic?
Yep.
Yes, it's got an x squared. X squared is the highest one. Yes, that's a quadratic. Look. Wait, could we make it equal 0? Yeah, -10, -10. And then you'd have it in general form. So good catch, Aaron. C, is that a quadratic?
No.
No, there's no x squared. So no, you have a check, an x. D, you sure? Right, you can't have a cube. Why is C not? Because there's no x squared. Look at D. Does D work? No, because there's an x cubed, and we're not allowed x cubes. X squared has to be the highest exponent we get. Question. To solve a quadratic equation, an equation with 2 binomial factors, we need to use the zero product property. We talked about this yesterday. Some of you were very confused, but we introduced it, and now we're going to talk about it a little bit further in depth. The zero product property means that 0 times anything is 0. So to solve these questions, we take advantage of that. If we take a quadratic and we write it in general form, so it looks like that. If we can factor that quadratic to look like this, we can use the zero product rule to help us. The only way that statement is true is if the first binomial is equal to 0 or the second binomial is equal to 0. If one of them is equal to 0, then this must be true. This question, what's an example of what x could be to make that right? So look at the first binomial. What does x have to be to make that equal to 0? -a. So your first answer would be x is equal to -a. What's another answer it could be? X could be -b, because that would make the second one 0. So if you can make either binomial 0, that's your answer. So this actually has 2 answers. The answers are x equals -a and x equals -b. So you have 2 answers for these quadratics. Remember we talked about this yesterday. It said, is this a factor? And I said a really easy way to check is just put in the negative of it. We were doing this without even talking about it. We're almost there. We'll get a couple questions. Solve the equation, verify your solution. I'm going to write out a little cheat sheet of what you need to do. Okay? So you might want to write this somewhere on your notes, maybe on the back page. You guys have a blank back page? No, because it's teach one whole book, right? Okay, then write it on the side somewhere. Your first step to solving these things. Your first step is write in general form. General form is ax squared plus bx plus c equals 0. That's always your first step. Write it in general form. Your second step is always going to be take out your greatest common factor. Greatest common factor, GCF. Your third step is factor. Using whatever method you need to use. A lot of you guys use diamond. That's fine. So factor, and I'm going to put in brackets, diamond. And your last step is find a solution. So find what x could be. Find your solution. So once you're in the factors, what could x be? Find solution. What is x? Yeah, but we don't really focus on it.
What was the first starting factor?
So if you look at the first one, the first step is write in general form. Is it in general form?
Yep.
Yes. First step is done. Second step, take out your greatest common factor. 10. There isn't one. So we're done step 2. Step 3, factor it diamond style.
8.
Yes. So if you're going to diamond method that, you would get 8 and 7 on the side. Can I erase this so I can
Well,
see
8
it?
negative 7.
Yeah. Can I erase that?
Yeah.
Speak now for hold your peace. I was at my brother's wedding this summer, and they never said that line. They're like, speak now for hold your peace, and I missed my chance. You imagine? They don't say that anymore? Too many people actually do it. Speak now for hold your peace when someone's getting married. Like, if somebody thinks you shouldn't get married, they stand up and you're like, no, don't do it. Yeah, like, by the way, still gonna get married, now we're just not friends.
Yeah, I think that's more important back in the days.
Or if it's like a week before the wedding.
Yeah, why couldn't you tell me 2 hours ago? Okay. Oh, okay. Really my older brother. Anyway, hey, we did all the steps. We need to diamond steps. So, on the top is A times C. On the bottom is 1. On the sides is 8 plus, negative 7. Yeah, I could erase it. That means your factors are x plus 8, x minus 7. And you guys have been doing this for a year now. And I'm tutoring somebody in college right now, university, and she's in a math course, and they're doing this. Like, this never really goes away if you go to post-secondary. They didn't teach diamond method, they taught decomposition, and then I showed her diamond method, and she's kind of like loving it.
My sister's at me right now, and she's in like the chemical engineering thing, and they're doing like stuff like this, and everyone else is doing this really hard way, and none of them know how to do the diamond method.
Yeah.
So show everyone.
Yeah, I never knew how to diamond method until I came here. Like, I've never heard of it before. I think Shaw got it from someone. Shaw learned it from somebody, and Shaw brought it here. Anyway,
We did it back in BC.
the only difference now is it's equal to 0. So you've got 2 binomials, but it's still equal to 0. That never went away. So what could x be?
Positive 7, negative 8.
Yeah. So x is equal to negative 8 and 7. And you write it like that. So You go x.
Opposite of what the second thing is.
It doesn't matter the order. So you could go 7, comma, negative 8,
But it
or
just-
negative 8, comma, 7.
it's not-
Just write it as 1, and write it all together, and you switch the signs. And the reason you switch the signs is because negative 8 is what would make that first thing equal to 0. We need these to equal 0, so the sign is opposite. London. Yeah, so if you graph this right now, if you graph that equation, what you would get is you get a graph that looks like this. And these 2 points are negative 8 and 7. You're finding x-intercept. Aaron.
Well, I was really like, always confused. Didn't you actually ask just like the question?
Like if you look right back at the original question, and if you look at that and we're like, oh yeah, 7 squared 49 plus 7 is 56. That would balance out. Yeah, you can do that, I guess.
But
I mean, but you wouldn't get the negative 8. You would miss the second answer. So you wouldn't get it right. It's both answers.
Don't do it that way.
Always factor. Okay. B. Guys, we've just done the easy one. That's it. So let's please pay attention. Look at B. What's your first step? General form. First step is general form. Right now, we don't have 0 on the right. We have a negative 20x on the right. So we're going to move it over by adding 20x to both sides. Good question. If you guys were to look at this right now, I bet you a lot of you that we don't have a trinomial, we can't do this. We don't have a difference of squares either. But what you do have is follow step 2, which says greatest common factor. Take out your greatest common factor. It's 5x. Take out a 5x, and on the inside you're left with x plus 4 equals 0. And what you have now is something times something equals 0. We're good. There's no more factoring that needs to be done. There's no more factoring that can be done. So what you do is figure out what x could be. What would make this first chunk equal to 0?
0.
X could equal 0 for the first chunk. What would make this second chunk 0?
-4.
If x were negative, that second chunk would be 0. It might not be a binomial times a binomial, but it is something times something, and we can take advantage of that. So for this question, x is equal to 0, comma, -4. So you did step 1, you did step 2, you didn't need to do step 3. You didn't need to factor that method. And step 4 was just answer the question, which we did. C. C is a little tricky. A lot of people are going to want to look at C and just say that the answer would be whatever makes that 0, whatever makes that 0. But the issue is, you're not in general form. So you need to FOIL it. And you need to move the 3 over. If this 3 was at 0, you would be fine. You wouldn't need to FOIL it. But it's not equal to 0.
After.
That's another good question. You can do whichever order you want. I'm going to FOIL first, because then I won't get confused on where the 3 is. So we're going to FOIL first. The first terms times each other are 2x squared. The outside is 2x. The inside is minus 3x. And the last one is negative 3, and it's all equal to 3. This is why I left the 3 on the right, because it's easy to get confused if you try to move it over at the same time. To get into general form, this 3 needs to move to the other side, because everything has to be equal to 0. So minus 3 from both sides. And now you have general form. 2x squared minus x minus 6 is equal to 0. Now you're in general form. If you lost of what I did there, 2x minus 3x is minus x. Negative 3 minus 3 is negative 6. I subtracted from both sides because I had a positive 3 on the right side. And the only way to get rid of a positive 3 is to subtract 3 from it. So I've moved that 3 to the other side. Now, greatest common factor. There isn't one. So, diamond method. What's on the top of our diamond? Negative 12. On the bottom, negative 1. Things that multiply to be negative 12 add to be negative 1. Negative 4 and 3. So now we're going to make our factors, which is 2x minus 4 times 2x plus 3 equals 0. We need to divide one of these by 2. The first one divides nicely by 2, so that's what we're going to do. And we have x minus 2 times 2x plus 3 equals 0. And I hope that you notice your first binomial is quite easy to figure out what x needs to be. The second binomial, not so much. So I'm going to show you what you need to do. What would make the first binomial equal 0? That's 2. So the first one is just going to be positive 2. The second one going to be a little bit more confusing, so I'm going to do it on the side in blue. What's our goal for the second binomial? What are we trying to figure out? Make it equal to 0. So what I'm going to do is 2x plus 3 equals 0. That's our goal. We want that second binomial to be 0. So if you write out the equation, it equal to 0. And now solve for x. Minus 3 from both sides. And you have 2x equals negative 3. Divide both sides by 2. And you have x is equal to negative 3 over 2. And that'll be your second answer. I'm going to run through that again. I got some. So, leave it as a fraction. You could say x is equal to negative 1.5. 1.5x, yeah. That's the same thing, right? 1.5 and 3 over 2, the same thing. You're probably going to see it as 3 over 2 on maybe 1.5 because it's a nice test. So, quick rewind. We broke it down to 2 binomials. We want to use the zero product rule, knowing that anything times a 0 is equal to 0. So we figure out what x value makes each binomial 0. The first binomial, if we want it to equal 0, x has to be 2. The second binomial, if we want it to be equal to 0, x is going to equal some weird number that we need to figure out. To figure it out, we started a new equation. We took the second binomial and we made it equal to 0, since that's what we want to do. and then we isolate it for x. Subtract 3 from both sides, then divide by 2. And that gives you your second x value. So if you were to write this answer out, you would just write x is equal to 2 comma negative 3 over 2, or negative 1. Whatever you're comfortable with, I guess. Last slide. The first one, nice and easy. Second one, not so much. Third one, bit of a trick to it. Try all 3 on your own. I'll write the answers up on the board. Try them on your own. The first one, super easy. Diamond method. Negative 8 on the top, negative 2 on the bottom, and you should have got x minus 4 times x plus 2. A lot of you guys did that one. That's awesome. The second one, there's a couple tricks to it. You need to move the 12x over, so minus 12x is to the middle. And then you need to take your greatest common factor out. So your greatest common factor was a 2. So you have 2 on the outside. And that should have been your resulting after you moved the 12 over. In fact, you'll get 2.
We didn't take it out, right?
Okay, that's fine. You'll get to the same spot that I'm going anyway.
Okay.
If you didn't take out the 2, I'll show you what's a little different about it. Ty.
That's not a mark.
Yeah, that would probably be a mark. And if you didn't take out the 2, that's fine. You can lose the mark. The mark is rearranging the 12. You factor the middle of this, and you should have found that you had 2x minus 3, sorry, plus 3, no, minus 3.
Lee Johnson and Summer Larson, please return to the Learning Support Center. Lee Johnson and Summer Larson, return to the Support Learning Center, please.
And I had a lot of questions. People were saying, do I write it twice? So do I say x is equal to 3 comma 3? That was some proposals. And you don't have to do that. You just write it once. And if you got here, you would actually rewrite it as 2 times x minus 3 squared. And now you see how we only need the x once. Because x minus 3 times x minus 3 is just x minus 3 squared. And that'll kind of help you see why you only need to write it once. Those of you who did do the greatest common factor, and there was a lot of you, you should have come up with 2x minus 6 times 2x minus 6. And you would have divided one of them out, so it would have actually been x minus. You guys got that, right? Those of you who didn't do your greatest common factor?
Yeah. 2x minus 6 and 2x minus 6.
Hey, you forgot to take out a 2 at the end on one of them. Right? Yeah, because if you did your first terms, you'd have 4x squared. Remember, you have to divide one of them by 2?
Yeah, I divided.
Okay. Greatest common factor of 2 comes out of this first one, which is how you get to the exact same spot we did. Just a different route. And if you didn't even do that, you still get the right answer because 3 still plugs in.
Yeah.
So no matter what, you're good.
That's weird. It's like 2x minus 6, 2x minus 6. It's like that.
Yeah, it should have been, the other one should have been an x minus 3. I'll show you. I'll come over to it. Okay, the last one. The last one caused the most offense. So, move the 4x over. London Bailey, most of it. Thank you. You move the 4x over, so you should have had 2x squared minus 4x equals 0. take out your greatest common factor of 2 and of x. So it's 2x on the outside, x minus 2 on the inside equals 0. The first one, the only way to get that 0 is if x is 0. The second one, the only way to get that to be 0 is if x is, and that's your answer. Any questions with these?
Well, wouldn't the x equals 3 look good? Would it just be like